Yeah, today's lecture is on maps and aerial photographs. So students, so we will read some basic concepts of mapping and aerial photography in this lecture. So with that, we will see what is a very first we will see what is a cadastral mapping. Cadastral, cadastral mapping. Generally, these maps can be compared. This is nothing but it will give some information about the ownership of the land. It will give some interest, some it will give some input. It will give it is a parcel of records, or it is a parcel of geometry or linked records, such as who is the ownership and what is the value of that particular cadastry. So if you want a proper or a formal definition for cadastry in cadastral mapping, you want a proper definition for cadastry. It is a parcel based and upon a date land information. It has a up-to-date land information. It is a pakka information will be there. That means, for example, so in one area there is a 1 acre of land is there. So in 1950 it is in under some person name, but after in 2020, in 2020 or 2021, that land may be shifted to another person. So it will be always be, that map will be up-to-date information containing records of land that describe the geometry of the parcel. Yes, some geometry will be there. Sometimes, for example, if the land may go for some canal purpose or something, that one also will be recorded in this cadastral mapping. So geometry parcels of and linked records to such as natural interest means just what I said about that canal, all those things, and ownership, and we will discuss about the ownership, who is the owner of that particular land, and the value of the parcel and improvements. So it will give value also. So for example, the land in Hyderabad is quite different. The land in somewhere in different areas will be different. So this cadastre is nothing but it's a parcel. It is a parcel of land based on parcel based up to date information will be there regarding the geometry and the ownership and the value also. So this definition was given with the FIG in 2005. So let us come to the cadastral survey. So in cadastral survey only they use cadastral mapping. In cadastral survey, documentation of boundaries of land ownership. It will give the documentation. So in our agriculture aspect, who is the owner? Farmer is the owner. So farmer will have the recording will be there in that mapping. So by production of documents, yeah, it will be there. So that ownership will be completely dependent by the owner documents, diagrams. Just our friend have given this example, and sketches. Previously, when there is no this much of big technology, nowadays we are using computer images and all those things, but in olden days they have used it with the rough sketches will be there, and plans, they will go plans and charts. Especially whenever you go to your gram panchayat, the village panchayat office, you can see that village charts in the mode of cadastral mapping only. And maps is generally what we discussed. So they are originally used to ensure the reliable facts of the land valuation taxation. So why, sir, why this cadastral mapping what mostly used when India was very.
बन जा बंदे अब पैसा आया 8 बजे पैसा नहीं जोनी अब निहाल कर
So
भुर्रा मिला जा तो वो
so cadastral survey documents, it will give some ownership documents and diagram and sketches and plans. It all will do. So mostly this cadastral mapping are used in reliable for land valuation students. So to find out what is the value of land and major purposes. When India was when India was under anyway, so they are originally used to ensure the reliable facts of land valuation. So this cadastral map mostly use it for the valuation of land, how much value is there, and taxation. So generally, students, these are the three reasons: historical development of collecting lands, special purpose. Generally, when India was, and especially this Uttar Pradesh and Bihar people know this problem. This Jamindari Jagidari system was prevailing in very olden days before British period. So due to the heavy taxation, actually due to these systems only, those two states, especially Uttar Pradesh and Bihar, was completely till today. Why Uttar Pradesh and Bihar was facing a lot of problem is because heavy land collections and due to the prevailing of Jagirdari and Zamindari systems in the past. So that is a different aspects. Anyhow, this map is used for the historical development of collection of land tax, official purpose, mostly for taxation purpose. They use, especially how most of your people are, we will pay some tax for our house. How we will pay? Based on the area of distribution. So this tax, this land survey officer will come, they will count, they will calculate how much area of land, how much area was your house was fitted, and they will draw one map. Based on that, they will put some taxation for you. And widely adopted for the support of land registration, especially real estate purpose, the general land registration purpose. And there will be one number, student. Whenever a particular parcel of land was fitted in that particular cadastral map, they will give one number. That number is called survey number. So if anybody is from agriculture background, if you have a agriculture lands, definitely you will have the government of that particular state government. If you are from Uttar Pradesh, they will be government of Uttar Pradesh, or in government of Telangana or Andhra Pradesh. Every farmer will have one passbook. In that passbook, they will have this survey number will be there. So they will give some, that is the supporting document for the land, legal and land registry. That is a legal document for it. And also to improve the land development. This is also, and another aspect is called the land improvement also. So these are the major aspects why we do for the cadastral. So why we go for cadastral mapping. What is the need of cadastral? So these are the different aspects of cadastral mapping. So now we will see what is the next. So cadastral mapping. So what are the conditions will be served? Inventory management, mostly we'll go for inventory management, like parcel of boundaries. Inventory management is just boundaries. What is a boundary for the one farmer to another, and unique parcel identifier, some cadastral plans. So some lands maybe from registration office. So mostly, most of you, if you are very aware about your agricultural land purpose, your agriculture students or agriculture families, mostly this problem is always prevail, the boundary problem. One farmer may go enter into the another farmer's land, another farmer will enter into another farmer. That will be some problem will be. What will happen, all of a sudden they will go to the revenue department, and survey person will come, and he will have a one proper map. That map is based on the cadastral map. So in olden days it is a plain sheet, they will come with a plain sheet, but nowadays everything is digitalized. So he will come with a tab, and he will enter the and he will enter the and he will enter the survey number, and he will found all the unique boundaries and unique identifiers. And registration of interest, this is what students, registration of interest, rights, restrictions and responsibilities, and interest owners. So that this particular cadastral map will give some interest. So register in the register office, it will show some interest, and interest and holders or owners also. It will give some protection to the owners also, especially students. For example, especially this everybody knows that this Bayaram minings is a big scam. Some 2005 or 6 people. What happened means, this Karnataka people, this Karnataka state government entered into the Andhra Pradesh, and started digging the mines in Andhra borders. Now it is Telangana, but in those days it was Andhra Pradesh, Bayaram. Yeah, I think so. Now it is. I think now it is also in Karnataka, Andhra only. But when it happened, all of a sudden, what happened? The survey people had came, and they have draw the cadastral map between the Andhra and Telangana, Karnataka. So there's a problem, and also the cadastral information computer system. So after a law, because in olden days they use only very very old maps, very old paper of sheet. They will come with big sketches and all this stuff. So cadastral information computer system dependent by so So mostly this cadastral information on a computer is completely determined by its cadastral identifiers. We will see what identifier means. These are the right, all those survey numbers, all and links, and it will give some information of the location, boundary, and land use. What kind of land, whether it is agriculture land, real estate land, or any household or any residential land. So or any parks, any park is there, and compound distinguish with respect functions of the land use. Just so it will give some distinguishing how the land use, and technical fitting, main connection. So how the land was technically fitting, and land purpose for the local spatial development plan, and distinct attribution for the real estate purpose, as we discussed, especially in surface and values. So this cadastral map completely will give all this information. So it will give the information regarding what is the location will be there, and how much how the land should be used, and what is we can distinguish the land between one part. So in this particular land we can use for the public park purpose, and one particular land we can use for the digging some recreation ponds, etc. We can go for all those things. So this is the regarding cadastral map consisting. So these are the things which is present in the cadastral map. So next, so what the things we should require, sir? Mostly should the scale range should be around 1:1000 to 1:5000. This is the scale range. And follow the Gaussian map. Map projections means the map which you see naturally. So there are different projections. Are there map projections means Gaussian map projection is one type of projection. Means in school days you have seen in globe they will in one map will be projected. Plane map will be projected. That is one type of projections. And spheroidal, what you see your in globe model they will project. That is called the spheroidal purpose. Datum need Everest spheroidal place, and square method is there. So these are different projections. If you go very in depth about those map projections, it will become you will get a lot of confusion. So I just remember it needs some Gaussian projections and some average spheroidal projections will be there, and map consisting of some standardized, including symbols will be there. They will symbols, or it will use some, what you will say, it will use some numbers also. And also units are mostly will be square meters. Previously, students in very olden days before British India rule, they will go for miles, inches. They will go. They have one, but nowadays everything is converted into square meters. So these are the things, and this is the scale. These are the requirements for the cadastral mapping. So cadastral map consisting of spatial information. What are the spatial informations? Property parcel boundaries will be there. Geodicted control moment, that means latitude and longitude will be there. Assignments and rights of ways. I mean, easement, that means which area land is suitable for the road, what are the roads, which area covered with the roads or highways. Building fruit means which area was covered with some buildings, and administrative buildings means some survey officer or something where it will give all the spatial information. Boundary parcels, some residential homes, some geodal control, some particular points, and what are the which are the roads, especially right way of road means generally which area was covered by the roads and all those. Textual information, generally property identifier, who is the particular person of that, who is the particular person of property identifier, and proper property address, what is the particular address, and surveyor identifier. So surveyor also will have some identifier. The document coordinate reference system will be, so coordinate reference, so based on the coordinate and all the discrimination will be there. So it is nothing but student, it is all your survey number, where is your land located, what is the longitude, latitude, who is the owner, what is the owner name, how much land is there, what type of land it is, what he is going to use. And especially students nowadays, everybody knows that this Pradhan Mantri Fasal Bima Yojana also is completely given by I don't know, mostly they may use this type of technology, which type of crop they are growing, how much acres they were using, all those things. So this is regarding the cadastral map. So basic approaches, what will be there for a cadastral surveying? How should we draw for a cadastral? We have to go for ground survey techniques. So generally, surveying is, as we discussed, there are detailed survey, semi-detailed survey, reconnaissance survey. So detailed reconnaissance survey, all this type of survey. So we should go for ground truth. Very first, we have to go to the field. Then we have to see what is the landform, what is the topographic conditions are there, what is the climatic conditions are there, and how the profile was developed. So you have to go for ground truthing combinations, combining of photogrammetry and remote sensing. We know what is photography, we'll see today, and remote sensing, what is the meaning, and ground survey techniques. This is what. So by combining all this knowledge, so we will combine the knowledge of our aerial photography, or nowadays aerial photography is not that much famous. We're using remote sensing data only. So remote sensing data and ground survey, we combine all this knowledge, then we will come to some conclusion. So ground survey techniques are completely based on the cadastral survey systems and photogrammetry. We will discuss what is photogram, what is a photo aerial photography. We will see all this. As only use it for last 30 years. Yeah, this is what. So photogrammetry is not that much famous nowadays. No one is using. We are mostly using for remote sensing data or something. Satellite images are used. Just Google Maps, Google Earth, all this. So Google ground survey is usually component of land registration towards the convey based mostly on the user. Completely ground survey is completely depend upon the land registration, for the component of land registration toward the conveyance based mainly on the users. Mostly total station, real-time kinematics, GPS survey, all these things. So we are used this GPS survey. GPS survey means, I think, if anybody has seen this sugarcane people, or they will put some dots, some points, how much area of sugarcane was crop was gone, to calculate the area of all those things. Even in soil science, for doing a survey nowadays, we are using GPS sampling. So wherever we collect the sample, we will collect the GPS and geographic information system of grid. So it is a combination of GS. So we will combine some information with cadastral maps. Azimuthal transform company. Azimuthal means this is a azimuthal projections. This is one type of projection, student cylinder projections will be there. So like this, transverse computation. So all this, we will combine all this, and finally we will plot a cadastral map. We will be around some 70 sheets. It's a just like your A4 sheet. There is one type of sheets are there. Control points are derived from the transverse computation. Control points. So computer control points, the points which are collected from the ground survey. So theoretically, it is very difficult for you to understand, but I will show one map. Definitely, you will get some idea. So regarding what is that? Yeah, this is what students see. This is what the cadastral map examples. You can see roads. You can see some distinguish between the which area is which one. Here you can see one difference, and there some numbers are there. 156. These are the survey numbers. These are cadastral numbers will be given. So best example, student, this parcel of land belongs to one particular person. That particular person number is 171. This is one survey number, and also this is a road. Is the road. This is the road. So this land is completely covered under by the road. So for example, here you can see, for think here you can see, here you can see some different. All these are all some. Think this green area all completely agriculture fields, and all these houses. These are some residential complex. All this. So this is the typical example of cadastral map. This is how your cadastral map looks. So I hope this is regarding cadastral map is nothing but to give to it will give some information regarding who is the to give some ownership, who is the particular owner of that particular cadastral mapping, all those things. Coming to the next students, it is a topographic maps. Topography, it is nothing but it will give some graphic representation of features appearing on the earth's surface. So it will give information regarding many recreational uses, how widely we are application. It is justly completely how wide we are application. Cadastral map is, it will give just a information. Give where it is opening, where who is the owner of that particular, what is the survey number, etc., etc. will get. But in topographic maps are used widely used for application of recreational use. So generally and hiking. So which land is for hiking? Some recreation means holiday purpose, urban planning. Especially if you want to go for urban planning, we can go for topographic maps. Especially Chandigarh was completely used by this topographic map because Chandigarh is a planned city. That's why it is a very clean and neat city in India. And surveying, mining. If you want to do any mining aspects, we have to go for topographic. And some emergency management. Some any disaster, we have to go for all those. So anyhow, student, the following information completely prevail in the topographic. What are those? Culture. So culture means nothing. Hydrography, relief, and vestige. So these are the three things which mostly we will see in the topographic. What are those? In culture, we can see roads, buildings, urban development, and railways, airports, name of the places. So we will give some names. And geographical position features. So we'll give some geographical positions, administrative boundaries, state and international boundaries, and this. See, it is somewhat extensive when compared to the cadastral map. Administrative blocks and state and international. So it will give some clear-cut boundaries between the different states in India or some international boundaries also. And hydrological, especially, it will give the information regarding the lakes. So where the Mahanadi river was present, where the Godavari Nadi is, where the Ganga Nadi is present. So it will give some information regarding this hydrography and relief, and also it will give some information regarding the mountains, valleys, cliffs, and all this. So by getting this, we can go for relief, especially for hiking. We need some this type of relief only we need, and vegetation, especially which areas comes under the woody area, which area comes under the forest, or which areas comes under the vineyard and orchards. So we will see all those things. So regarding this cultural hydrography relief, which covers all this topography means it completely gives geographic representation appear on the Earth's surface. So the graphic representation of features appear on the Earth's surface. So whatever the features are appeared on the Earth's surface. This is regarding, don't confuse with the cadastry and topography, both are quite different. So this is the topography. You can see the major difference between the cadastral map and this topographic map. See, you can see some lakes are there in this map, and you can see some different boundaries, some valleys are there. You can see some different, mostly some rivers here, some river flow is there, some valleys are there. These are some mountain oceans. So this is regarding the topographic map. So topographic map is different in cadastral mapping. So this is regarding the topographic map. Mostly we agriculture generally we will collect the maps. We actually we won't draw these two maps. We'll draw a fertility map generally. How we will do? How we will draw fertility map? We will select a particular parcel of land. Say for example, if I selected one particular area of any state, what I will do? I will collect a sample based on my interest. So for example, if the area was very small, so for example, my objective is to find out the fertility status of one big area, some big district, like so for example Ayodhya. So I want to do a fertility mapping for Ayodhya. Ayodhya is somewhat very big, so I will take a GPS and with all my equipment like auger, sampling, everything, and I will dig some profiles and collect. And where I am collecting the particular sample, I will collect the what is the coordinates, geological coordinates. There will be some this longitude, latitude coordinates. So I will collect that coordinates and I will note down in the memory card of the GPS. So after collecting all these samples, I will do analysis. So for example, some one user, just for example, I will show. So for example, see this is a particular area. This is fine. So maps generally won't be a straight line in India. So this is a particular area. What I did, so I want to collect a sample here. What I did, I will stand here. I will collect the sample and I will note down the what is the longitude latitude. So these are the longitude latitude. Say for example, if I get 0.56, it will be like this 5, 6, 7, 8 degrees something it is. So I will do analysis in this particular area, and so for example here the nitrogen was very high. Here the nitrogen was very high. I will collect. So like this, I will collect randomly. I will collect randomly based on the distance. So one sample, maybe another sample. So based on, and also I will take the profile data also. I will dig the profile. So for example, this is a lowland, this is a highland, this is a very deep lowland. So I will collect some different lands. I will collect the land. I will dig the profile. I will study the characteristics of the particular profile, and I will come into some conclusion. So then what I will do after getting all this data, so I will get each and every data. So I will get the nitrogen content of this particular area. I will get the phosphorus, all the physical chemical characteristics I will study. Then what I will do, I will upload this information in one particular software called, what is that software? It is called the ARC.
RGs.
Yes, RGS, very famous software. RGS, we use this RGS. Nowadays, there are many RGS Pro also coming. So very nowadays, very RGS Pro is very advanced when coming to the RGS. So RGS Pro we use. So we'll upload this in the RGS, and it will process the data based on its longitude latitude with the help of internet. We can produce one map called, that is called the fertility map. So for each and every, for nitrogen, I will draw one map. For phosphorus, like this, I will draw another map. So like this, I will get some understanding. So what will happen? It is a record. So for example, in 2021, one particular person did this research. So he found that nitrogen was very high in this particular parcel of land. Phosphorus was medium, is high, is medium, whereas potassium was somewhat low. Just think, most of Indian cases, potassium won't be low, but think it is a potassium also. But after some 2050 or something, another person will come, and what he will do, he will refer this, and if he is found any major changes, if all of a sudden, see for example, all the nutrients was low, what will happen? Then he will find out so in 2021 it was like this, but why do what happened? So it will give some clear-cut idea about the management, resource management. This is what a very important aspect in GS, GPS, fertility mapping analysis. It is a clear-cut record. Collection data is very important. That data should be very accurate and proper management. So as much as possible, we should be very careful in analysis part in laboratory. So we should avoid errors as much as possible. So it is very difficult at initial stage, but we should, we always says quality is not a standard, it is a habit. Everyone should make some habit of maintaining some quality in your research. So like these students, we will get that is a fertility map which we generally do in agriculture purpose. Actually, this is my research, that's why I've taken someone more interest. Anyhow, this is what regarding the maps. And now we will see another important topic called aerial photographs. Aerial photographs are not that much famous nowadays, but it's present in your syllabus. We will discuss about these things. I'm giving some peculiar idea about the aerial photograph, students, but I'm not going very in depth about aerial photography because you will be very tense and confused. If you want, I will provide any material for this. Anyhow, coming to the subject, aerial photography. The photographs taken from the aircraft or helicopter using precision camera is termed as aerial photographs. So nowadays, anybody using aerial photographs or helicopters? No one is using. Instead of what we are using, can anyone answer? In olden days means some 5-6 years back, this is okay. They're taking aerial photographs from aircraft and helicopters they are using. That is called aerial photography. But nowadays is using aircraft. Anybody using aircraft? What they are using instead of aircraft, what we are using? Any idea?
Satellites.
What?
Satellites.
Okay, satellites, that is different.
Satellites.
Yeah. Satellites is advanced. That is advanced. We are taking satellite images and we are combining that one with the GS GPS. That is okay. That is accepted. But instead of aircrafts, nowadays we are using one equipment. What is that? Regularly we see in our marriage functions. Even nowadays they are using in cinema industry.
So drone camera.
Yes, drone camera. Yes, drone camera. We are using drone camera. So instead of that, nowadays we are using drone camera. Anyhow, this aerial photograph was not that much famous. I know that is what are the photographs was taken from the aircraft, that is called aerial photographs. The photographs so obtained found to be indispensable tool for the topographic mapping and interpreting images. So this mapping, students, what is the use of this aerial photography? Whenever we take a aerial photography, what will happen? It will give some basic idea about the preparing for the topographic map, what we have discussed in the past. So generally, students, in India mostly when we have done this photographic image, what is the historical background means in 1920, especially in 1920 when we go for first large scale aerial photography of Agra. No, now we know what is Agra city were obtained. So in 1920 we have taken the India was first taken the aerial photography. Subsequently, what will happen? Air Survey Party, that in those days that's called Air Survey Party of Survey of India, took up aerial survey of some delta forest regions, which is completely during 1920 and 24. Like this in 1920s and 24, the day back some Agra they have taken in Agra, the Agra city they have taken on aerial photograph, and some delta forest they have. Subsequently several, so like this when it started from Agra. Subsequently, what will happen? What happened? We have taken many aerial photographs, advanced methods of mapping aerial. So after that we have to date. So mostly today, where these aerial photographs are made in India was aerial photograph India is carried out by the entire country under the supervision of the Directorate of Air Survey. That is nothing but Survey of India. So mostly Survey of India is going to take place, which is present in the New Delhi. So mostly three flying agencies are there. So most of taking these aerial photographies in India, mostly three agencies are there. What are those? Indian Air Force. Naturally, without Air Force, we can't do. Air Survey Company is and Kolkata, which is present in Kolkata, and National Remote Sensing Agency. Where it is located? National Remote Sensing Agency. Can anyone answer?
Dehradun. Dehradun.
Dehradun. Can anyone give any other answer? National Remote Sensing Agency. Okay. I have some. I will link in maybe Hyderabad or Dehradun. I think so. Have been officially authorized. So after of the combination of all this Air Force, Air Survey of Air Survey Company or the Survey of India, they are taking part in this aerial photography. So this is regarding some sort of historical background regarding in what is this regarding this taking of aerial photographs. So anyhow, students, now we will see what is the use of aerial photographs. So mostly these aerial photographs are used in topographical mapping and interpretations. Generally we because by the help of this aerial photographs only, we can get some conclusion how to prepare a topograph. So it will give some foundation for preparing of topographic mapping and interpretations. So these are the these two different maps are used to development for the development. What happened? They have gone for the so by the use of this, we have get the department development of a few areas. What is called the photogrammetry or photo or image interpretation. So photogrammetry. Anybody have photogrammetry meaning? What is photogrammetry? Photogrammetry is nothing but the science and technology of taking reliable measurements from aerial photographs. It will give some calculate some measurements. It will give some measurements, reliable measurements of the aerial photography. And image interpretation is just interpreting what is a particular area. It is a science of interpreting. So these two independent but related to the science. So generally, after aerial photography, these two departments came into light. Both are independent, but they are related. So photogrammetry is nothing but a science of technology making reliable measurements of aerial photography, and the principles of using photography is related to the precise and measures related to the length, breadth, height of such photograph. Generally, this photogrammetry it will give the not only just taking photograph, it will give some length. What is the length of that photo for that particular area, and breadth and height also. So this photogrammetry will give some idea about all this. Hence, they are used for the data source for the creating and updating topographic. Generally, for updating students. Say for example, students in 1920, how the Delhi looks. So I have no idea about Delhi. In 1920 or in 19 before British period, how the Madras city. Now it is Chennai. Previous it is called Madras city. Madras city was something different. That Kuvam river was very fresh in those days. But in those days, taking photograph was completely in those days the topography of Madras or Chennai presently it is completely different. But now in 2021, if you want to try to update our topography, these aerial photographs are completely useful. So in 1920s or before independence, Kuvam river was very fresh water. Actually, that river was completely used for drinking purpose for the city. But now there's a big drainage in Chennai. That is Chennai city. That's a different year. So to update this type of knowledge. So in 1920 the river was like this. In 2020 the river was like this. To update all these things, we need the photogrammetry. So we need the data source and creating updating topographic maps. So this is regarding the photogrammetry. Coming to the next students, image interpretation. So image interpretation is nothing but just identifying, just interpreting. What interpreting means? Just analyzing. It is the art of identifying of an object and judging their relative significance. So we have to judge the particular condition. So for example, if you take a photograph of a big mountain, which always have some landslides. So in that particular area, you can't construct a village. It's very difficult because all of a sudden, any night, the cliff may be, the landslide may happen. What will happen? The entire village will be under the debris of that particular mountain. So that is understanding that that's such type of identifying. So this is a particular cliff or particular mountain which is not safe. So we should not use this. The surrounding area is not. So just the interpretation. The principal image interpretations are applied for the obtain qualitative information from the aerial photographs such as land use, generally land use, land cover, topography. So generally nothing about how to use for the land. And trained interpreter can utilize the aerial photograph for analyze the land use changes. So if anybody have a capacity or any person was trained in particular aerial photography, so you can take some some ideas. You have some, you will have some idea regarding how the land should be used, all those things. So this is regarding the image interpretation. Interpretation of image analyzing. So coming to the next, students, advantages. What are the advantages, sir? So we have talked many things about aerial photography, etc. What are the advantages? So improved vintage points. So we can use, this is the improved vintage point, means we can see very clear cut of that particular area. We have some very beautiful view. We can have pure knowledge by using a bird eye view. Bird eye view means, whenever we see from any particular, from high mountain, we will get some bird eye view. Enable, so we can see many earth surface features. We can see some spatial context also. We get the more information. Time freezing ability. So this aerial photography usually reduce the time of that particular. So it can be used for the historical record also. Just I said. So for example, the photograph was taken in now today we are taking photograph of particular Bhubaneswar city. I taken 2020. I have taken some aerial photography. In 2060 or 30, some person will come and he will take one photography. So based on that, he can compare. So how much greenery was present in those in 2020, how much green was present in 2060. So it will give some time freezing ability. It will be some historical record. So the photograph will give some historical record also. And broaden sensitivity. So sensitivity is very high, students. Students, our human eyes can see only up to one particular specific electromagnetic spectrum mode. That is visual spectrum. We can say up to visual spectrum only. What is the range of visual spectrum? 0.4 to 0.7 micrometers. But at the same time, cameras, films, where we use films, we can go up to 0.3 to 0.9 micrometers. So the visual capacity of the capacity of broad sensitivity in cameras, which is used for particularly for the aerial photography, is very high when compared with our human eye. So it will give some broad sensitivity. So these are the few advantages of aerial photography. So another one is called three-dimensional. Right? It's a three-dimensional. We can see the length, breadth, etc. It's a completely three-dimensional view. We can see how much we can get a very good. So seeing a particular object in three-dimensional view, more information as we generally we should we will see some info what we see regular photographs is what it is. It will give some three-dimensional view, very to give very advantage in aerial photography. So types of aerial photography, students. So we have discussed many things, all those things, type of aerial photography. So types of aerial photography completely divided or classified based on the camera axis, in which axis you are taking the photographs, scale, angular, under which angle you are taking photograph. Generally, we are having habit of taking photography. They know all these terms: camera axis, scale, angular, extent of coverage, how much area was covering by the film used. So everybody, especially the camera people who have a habit of photography. Photography is very noble profession, very interesting profession. If anybody have that idea, they know all these words: camera axis, scale, angular, how much area is covering, all those things. So based on this optical axis and scale, we have given these are the giving following aerial photographs. What are those, students? So based on the position of the camera axis, based on the camera axis, there are how many types are there, students? Based on the camera axis, aerial photographs are classified into three types: mostly vertical photographs, low oblique photographs, high oblique photographs. Vertical photographs. Anybody got any idea in your? Have you got any idea what is the meaning of vertical photographs? Any idea? If you have, anybody can share your knowledge. Okay, low oblique photograph, high oblique photograph may not be have, but anybody, what is a vertical photograph? Any idea? So like this, vertical photography and low oblique photography and high oblique photography. We will see one by one what is a vertical photograph. Like we will see that what is a vertical photograph. So vertical photography is nothing but taking an aerial photography with a two distinct axes formed from the camera lens center on towards the ground plane or other towards the photo plane. Also one image, then you will can understand. So the perpendicular dropping of the camera lens center to the ground plane is termed as the vertical axis. So whenever I will show one image, then you will get. So whenever a particular perpendicular dropping of a camera lens, so that lens for the focus centered towards the ground. So the focus of the lens is come centered to the ground plane is termed as the vertical axis. So the focus of that particular camera lens will be straight to the vertical axis. Vertically, it will go to the. Whereas plumb line, I will show what is a plumb line drawn from the axis center to the photo plane is known as photographic axis or optical axis. So the particular optical axis will grow, that is called the photographic axis. So whenever the photo plane is kept parallel to the ground plane, just after parallel to the ground plane, the two axes also coincide with each other. The photograph is so obtained is called the vertical photograph. So whenever you took a camera of the ground parallel to the ground and you click one photograph, that is called the vertical photograph. That particular length, the camera lens should be straight to the ground, and that optical photo plane, that plumb line should be same, should be cross that particular vertical line. So that is called the photographic or optical axis. So however, mostly students, it is very difficult, students, because our earth for us it is a very flat land, but naturally earth is not a perfect flat. It is a oval in shape. Earth is not a whenever if anybody have a boarded flight, generally if you see the ground won't looks very flat. It will be somewhat some dome. It will be some rounding shape will be there, some egg shape you can see, some bending shape. So it's very not very difficult. It's a perfect parallelism, as I said, between the two planes due to the fact that aircraft flies over a curved surface. So you can see curved surface. You can't say flat body of Earth. Whenever you go to a very high altitude, the Earth will be curved. You can see curved nature will be there. It won't be flat. What we seeing regularly, the land is not flat. It's a curve. Earth surface curve. So it is very difficult, students. We can't get perfect vertical angle, but then and there will be some tilt will be there between the angle. So that is acceptable, no problem. By taking that particular photograph is called the aerial photograph. I will show one image. Yeah, this is what, students. See, this is the photo plane axis. This is the camera lens, and this is the camera axis or vertical axis. Definitely should be around 90 degrees. This is the area covered. These are the lens. These are the focus lens. So it almost, this is the area covered if you take this. So this angle, students, generally you won't get perfect 90 degrees of Earth surface. Why? Because Earth was not a flat. What we see is not a flat. Earth was not flat body. It's a round. It is a globe body. It's a globe in nature. It has some curvature. So then and there, what we have, there will be some deviation of 3 degrees. Then and there, some minus 3 degrees. It will be 9 degrees. You can manage up to some. You can take error up to 3 degrees. So near photographs will be appear. So then and there will be some adjustment around the 3 degrees. So that is called the. So when we take more than 3 degrees, if you take error of more than 3 degrees, that particular photography is called the tilted photography. So the students, if it is 90 degrees, it is not possible. But then and there, if you have some disturbance of between 3 degrees of this 90 degree, then and then 90 degrees with 3 degree disturbance, okay, it is acceptable. So near vertical aerial photography, we can get here. But if we go for beyond the 3 degrees, 33 degrees, you will get the tilted photograph. You will get some tilted photograph things. You go for beyond. So this is the camera axis. Generally, this line was very difficult. It won't be 90 degrees in Earth's surface. For understanding, I'm saying, because Earth is not a flat body. It is a curvature. It is a globe in nature. It is a oval in shape. This is regarding the vertical aerial photography. But what is the oblique photography, sir? You will see this is a low oblique. So if we take a photography in different angle, especially who have a habit of taking photos, images with the camera, they know this type of low oblique. Generally, if you're taking a photo of a bird is different. But if you take a photo of a different angle, say from some side angle or lower angle, taking a neck part or all those things, it will give a different view. It will give a different view. The angle will be very quite different. So those, I think, there's a beauty of camera photography. They know all these things. So let us see what is the formality of this low objective. So an aerial photography is taken up in a deviation of 15 to 30 degrees in the camera axis. See, up to you can take from 15 to 30 degrees degrees up to this axis, this vertical axis. If there is 30 to 15, 30-degree camera axis from the vertical axis referred as low oblique photography. Remember students, if there is a tilt or if there is any angle change between 15 to 30 degrees from vertical axis, that particular photography is called low oblique. This kind of photography is completely used for the reconnaissance soil survey. See students, see the beauty of this. Here you can cover more area, but see here, it's quite different. So that's why we can use next. That's why we can use this. This is called the low oblique. Low oblique means there is some intentional deviation, student. This is not by accidentally. We will take intentional. That means by with our knowledge only, we will bend camera around with beyond the axis. We'll take around 15 to 30 degrees camera axis, vertical axis. So then we can get the low oblique photograph. Coming to the next, students, high oblique. Here's some more. We can take around intentionally. We can take around the 60 degrees. Can go for up to 60 degrees deviation from the vertical line intentionally. So naturally this type of photography is called high oblique photograph. So such photography is useful for mostly for the reconnaissance soil survey. This also we can use for the reconnaissance soil survey. We can use for reconnaissance soil survey. This is called the high oblique. So remember these things. What is the tilt? What is the high oblique? What is the low oblique? What is the vertical photograph? So this is regarding the vertical photograph. So what is the difference, sir? So what is the comparison between vertical and oblique photography? So these are the things. Just I made the comparison between the vertical. So mostly these, all these angles is we can't take exactly. There will be some coincidence. There is some deviation of 3 degrees, but intentionally we'll take 30 degrees deviation we can take from vertical axis. But here we intentionally will take more than 30 degrees, or we can go for up to 60 degrees. So horizons is very difficult. Is vertical horizons does appear. We can go for some extent, but here we can say horizons will be appeared. Coverage, here is a very small coverage, relatively larger area, here larger area. I'm showing you, if you see that images, we can get shape of here, we get a square. Here we can say some tetrapod, trapezoidal shape of map we can get. Photography scale is somewhat terrain and flat, decreases from foreground to background. Foreground means background is all those things. So all this we can get all those things. So these are the just comparison what we have seen. So what is the uses? Useful. These maps, these vertical photographs are used in topographical and thematic maps. Thematic map, the aim of our map, whether fertility map or fertility map, for example, thematic maps. This is used for the reconnaissance survey. It's called the illustrative purpose. We can use for the reconnaissance survey, and we can for other purpose also we can use this oblique. So these are just comparison. What I have said is said here. It's just a comparison between the different type of photograph. Now we will see what. So what is this, sir? Mostly aerial photography have a scales, large scale photographs, medium scale photograph, small scale photographs. What are those scales? We will see now. So large scale photographs. So mostly this large scale photograph has scale range of 1:15,000 larger. The photograph is classified as large scale photograph. So if you have 1:15,000 scale, it is called the large scale photograph. Medium scale, you can go for around 1:15 and 1:30,000. That's called the medium scale photograph. So small scale, it is beyond. If you go for more than 1:30,000, are reported as a small scale photography. So these are the different scales of the aerial photography. So these are the 1:15,000, 1:15,000 to 1:30,000. So small scale photography is nothing but 1:30,000. So these are the regarding with the aerial photography. So geometry apply. So there's a geometry also, students, that angle. So projections. So geometry is nothing but aerial projections. We have different projections in there. Geometry is projection. So what are the projections? Parallel projection, orthogonal projection, central projection, based on your camera axis, lens, and all those things. What are those projections? We'll discuss this. So parallel projections with just the focal length will be that. So for example, it's a projection rays that parallel but does not necessary to be perpendicular. So generally it will be parallel projection, but does not to be a perpendicular. Just for example, A, B, C, you can see L and L1. This is the parallel projection. Example for you, this is the parallel projection. And another one is called orthogonal projection. So there is a somewhat different, but here is somewhat. It's the special case parallel projections. Maps are orthogonal projections will be above ground. The advantage of this projection is distance, angle, and area of the plane are independent of the elevation difference. So you can see some advantage. There is no distance, may not be a distance, the angle are completely independent. So you can here also example orthogonal projection of a rays perpendicular to the line. So you can see some perpendicular straight with, but here, but previously this one may not be perpendicular, parallel projection. But here, sorry, but here you need a perpendicular to each other. So this is the now everything should be perpendicular. All the projection should be perpendicular. Coming to the next is called central projection. This is somewhat very interesting. Central projection. So all the rays should be in central projection. So mostly the projected rays, whatever the rays which you have released from the camera, maybe from A, B or B, small b, etc. All these things. So B and BB and CC passes through a common point called O. So here it will be some projections, which is called the perspective center. If the rays was coming from this common point, it is called the central projection. The image projected by the lens is treated as a central projection. So you can get some central projections. So A rays completely. So there are different angles. If you go very in depth about these things, you will get a different laws. You have to deal with different laws and all those things. Just remember for a basic idea, take a basic idea about this. What is the difference? Finally, we came here. What's the difference between map and aerial photography? We have learned what is the maps and we have learned what is the aerial photography. What is the major difference? What is the difference? We will see all these things. So this is the difference. Aerial photography. It is a central projection. It is a orthogonal projections. Here the geometry is incorrect. You can't go any because just we are taking photograph. That's all. We are not going for. There is no perfect geometry is not there. Distortion geometry is minimum at the center and increasing towards the edges of the photograph. So in center, the problem with the distortion is that the deviation is very minimum. But we go for edges of the photography. Definitely they will be on. So, but in map conditions, geometrically perfect representation will be there or earth projection. So map projections are completely different students. There is a azimuthal projection, cylinder projection, and some the different projections of map is there. That will deal in the cartography. Cartography is nothing but is a study of maps. The scale of photography is not uniform. There is no any uniform scale will be there. Completely different will be there. But the scale of map is uniform throughout the map extent. Here we can say, so for example, in one particular area, I will take one type of angle photography, or in the same area, if we cover in the same map or the same photography, we will get a particular, we will get another different projections will be there. And also here in aerial photography, enlargement reduction does not change the content of the photography and can easily carry it out. So here there will be no reductions or there will be no one kind of enlargements and all those things. But here you can say some raw drawing is a fresh. So you can go for reductions all those. Aerial photography are good for the inaccessible and inhospitable areas, especially whenever for example whenever with a particular where there is a very hilly areas or very mountain areas, we can go and take the aerial photograph very easily. But we can't go for topographic mapping. It is very difficult. We can't take all our equipment and we can't walk in the on that particular mountain areas. It's very difficult. So these are the difference between the map and aerial photography will be there. Some sort of quite differences. So with this, I'm ending the lecture. Thank you very much. And you can ask if you have any doubts. You can ask, and I will upload this class in the YouTube, and you can take this. Thank you very much.